Hey guys, it's Katie from Kestrel. Super excited for our Facebook Live tonight. We're here with Bryan Litz from Applied Ballistics, and we get to pick his brain for a full hour. So really excited to be here. Bryan, thank you so much for joining us.
Yeah, it's good to be on. Thanks for having me.
Yeah. So I know you've gotten to escape quarantine a little bit, right? You've gotten some shooting in?
Oh yeah. Yeah, we've had enough. I escaped recently, drove to Wyoming for the Night Force ELR Steel Challenge last weekend, and it was good. It was good to, it's been a long time since I had a road trip with that much time to think. So it was really good to get out.
Yeah, I'm very envious. In Pennsylvania, we're still a little bit locked down. So next week, though, I'm going to go shooting next week. So finally.
Okay, finally.
Yeah. What has been going on with AB? What's new with you guys?
We haven't been traveling much, but we've been doing a lot of shooting. The lab has been active. There's, a relatively small number of people that work there compared to like a typical workspace. So we've been able to continue our government projects and our, testing bullets for the library and supporting software. So this hasn't really slowed us down very much. If anything, it kind of, turn down the background noise on some things and let us focus on some stuff, which has been really nice. So it's I really can't complain, honestly, about how things have been going. But I'll tell you, we've wore out Michigan for shooting, though. We're ready to leave the state.
Hence the driving all the way to Wyoming, right?
Oh yeah. We've already had a couple of our mobile lab events get canceled or postponed for the earlier part of the year, and so they kind of stacked up now for the end of the year, and it's going to be a really busy second half of the year for us with that.
Yeah, well, we should talk about the mobile lab because we had it at our Kestrel shootout last year, and it was an incredible opportunity. I think about half of the shooters that were competing in our match were able to take advantage of it. Some of the guys even brought 2 rifles. And figured out, they decided based on the data they got from the AB mobile lab, which rifle they were going to shoot in the match, which was crazy to me.
Oh yeah, there's so much information that you can get. I mean, having the radar system itself is a novel capability for most shooters. You just don't normally get to see your bullet fly. You don't normally get to see the track. So just having that instrumentation there is really really fun and exciting, but also like having our crew there to talk about what it means. You've seen, we've seen thousands and thousands of radar tracks for, different bullets and barrels and speeds and combinations of muzzle brakes and suppressors. Like there's so many different things to learn about with it that, we can diagnose a lot from a radar testing session. And that combination of the instrumentation and expertise that we can bring to events and help shooters understand their equipment and how their bullets are flying, it's really an eye-opening experience. There's a lot that goes on with a bullet in flight that you either take for granted or misunderstand if you don't actually track it. And yeah, having the ability to track them, it's an incredible amount of information to make use of.
So do you think that some of your PDM knowledge, now that you've tested so many bullets as PDMs through so many different rifles, is that kind of adjusting, or do you go back and look at your custom drag models and readjust any numbers in that? Has that happened?
Yeah, so the idea of the custom drag model, the entry in the library that most shooters will select is that is the sum average or the culmination of like what it's likely to be the closest thing to what everybody has. So, after we've tested a number of PDMs, we sort of average those together and combine them into the collective custom drag model and BCs that anyone will get whenever they select it. Like in the very beginning, when we get a bullet for the first time, we'll test it out of 1 or 2 of our test rifles and, either take the 1 or average the 2. And that is our assessment of that bullet's performance. But then down the road, if it's a popular bullet and many people shoot it and get PDMs, then we kind of use that collective information to refine what the average model is. And most of the time, Katie, those PDMs are barely distinguishable from the average CDM. But once in a while, like this is the value in doing it, is to know for sure, because once in a while, a shooter will have a particular barrel or, you know, muzzle device or something that causes a bullet to be launched or fly differently from their gun. And the only way to know that is to instrument that one specifically. And so once in a while, we'll get a PDM that's different enough from what they would otherwise use that it's worth doing. So, you know, most of the time you just get a confirmation that your bullets are flying like they're supposed to. But once in a while you find out that it is actually different for some reason, and we can get an exact model of that.
Yeah, and I imagine to all those different events, you can kind of see trends too of what caliber is most popular for, you know, the southeast area of the PRS matches versus ELR guys. And
oh yeah,
right?
yeah, I think and we're seeing trends, and I think we're seeing those trends among the most serious shooters, because, you know, people that come to events where the lab is, they're, you know, they tend to be your more professional, your more persistent shooters. You know, they're getting out and about to events that we're going to. So we're getting a cross section of the stuff that's working. You know, I mean, there's a lot of just collective information, you know, like the number of 6mm 105 hybrids that were shot and 6mm 140 or 6.5 140 hybrids. Just knowing what bullets are being used is good information, but then seeing the range of performance among those bullets is also really enlightening too.
What is your plan? So when we posted this, we had a lot of different people coming in and saying, oh, when is this bullet going to get added to my bullet library? So how do you do that, and how frequently are you guys adding bullets into the library?
Well, our protocol for that is that, first of all, we are trying to keep an eye on the bullet industry and seeing when new things are pushed and be proactive about, you know, buying those bullets and getting them tested. But we also encourage shooters to contact us directly, you know, either emails or even Facebook messages to our AB Facebook page. And if there's a bullet that they have that they're interested in, then we want to get it on our list. The idea is that our library contains all of the bullets that anyone needs. Now, if a major brand comes out with a new bullet that's square in the middle of a competitive category and a lot of people want it, that's going to be a higher priority on our list than maybe a guy that's making his own bullets and he's the only one shooting them. But honestly, any bullets that get sent to us or that get suggested to us, they go on our list for testing eventually, and they make it into our library. We have a running list of what's been requested, what bullets we have, and then whenever they're tested. And whenever we do a test and we push an update, we try to list off what bullets have been tested in the update. So when you see your app is updated, it'll give you an indication of what it was that we tested, so you'll know if your bullet's in there or not.
What about 22 long range? Everybody's asking about it. Everybody is getting into it. I think you and I had talked earlier this year, maybe at SHOT Show, that you were starting to get into it as well.
Mm-hmm. Yeah, and I think one of the common questions that shooters have is, you know, what kind of equipment or ballistic solvers do I need to work with 22? And the reality is the Kestrel as it is will work with 22. There's no reason that it won't. But there's a few things that are different. And so we're testing and adding rimfire types to the library as well. So you can just select one, build it like you would a normal gun, and expect that it's going to work the same way. But being 22 rimfire, there are a couple things that it's important to understand, and it has to do with the speed regime of the bullet, like how much slower it's going. Like with centerfire, you know, if you have supersonic muzzle velocities, the bullet's 2 or 3 times the speed of sound. So the aerodynamic drag is very high. You're talking 20, 30 Gs of aerodynamic drag on the bullet to slow it down really quickly. And that makes it very sensitive to its geometric features, makes it very sensitive to what the BC is. You know, if we miss the BC by 1 or 2% on a supersonic bullet, on a centerfire bullet, that's going to show up as error in your trajectory prediction, you know, past 1,000 yards. But with a 22 bullet, because it's going so much slower, it is actually much less susceptible to what the BC is and even errors in the BC. So aerodynamic drag is quadratic, which means if you double the speed that you're going through the air, it doesn't double the drag, it quadruples it. And if you go 3 times the speed, then your aerodynamic drag is 8 times. So you're squaring the multiple of speed that you're at. So it really is, when you slow down, you're really non-linearly reducing the effect of how much BC matters. So all that to say that when you're shooting a 22 rimfire, if you have a few % error on your BC number, it's really not going to affect your trajectory that much. Now, what you trade that for, on the other hand, is that your trajectory predictions with 22 rimfire, and this goes for subsonic muzzle velocities across the board, is that the muzzle velocity is the thing that now becomes incredibly important. You know, with supersonic, you could miss your muzzle velocity by 10 or 15 feet per second and still hit most targets. You know, you'd be off a little bit, but you'll still hit most targets. With 22 rimfire, you know, you can try it, run a ballistics program out to 300 or 400 yards and change the muzzle velocity 15 feet per second and see how much that affects your drop. It's shocking how much. I mean, it's feet different that your bullet hits at as close as 300 or 400 yards with just a small difference in muzzle velocity, whereas the BC won't affect your trajectory that much. So the software and the tools work just the same for rimfire as they do for centerfire, but you're sensitive to different things in that speed regime. So I would say that's the most important fundamental thing to understand about using a Kestrel for rimfire or subsonic ballistics.
Right. So truing your muzzle velocity isn't possible because it's already subsonic, right?
Mm-hmm.
So how do you best calibrate your muzzle velocity in the Kestrel with shooting a rimfire or any subsonic round?
Well, the best is if you have a good chronograph that will measure it. But if you don't, I mean, the truing feature in the Kestrel is very convenient because how it works automatically, but it's not very difficult to true that by hand. I mean, that's one of the things that we've talked about with the Kestrel as far as adapting it to allow you to true muzzle velocity for subsonic things like rimfire. So that may someday be possible with the Kestrel to do that automatically. But aside from that, I mean, if you're a user and you imagine you put in, 1,020 feet per second and your prediction is too much drop than what you realized, well, you can just manually put in a higher muzzle velocity. I mean, it's not difficult to converge on your trued muzzle velocity for subsonic things by doing it manually.
Okay, so you can still adjust your muzzle velocity. You don't even go into the cal MV, you just play around with your muzzle velocity while you're sitting at the range and adjust it.
Yeah, I mean, that's
so you're
all.
Still matching point of aim, point of impact. It's just not in the formal part of doing cal MV.
Right. You're forced to do it manually. I mean, when you cal MV in the Kestrel, that's all it's doing. It's doing that, but it's doing it automatically. It's iterating and converging on what your muzzle velocity has to be for that observed drop. But because the Kestrel is currently set up to only do that for supersonic muzzle velocities, it won't do it for rimfire. So you could just do that simple iterative process by hand and arrive at your true muzzle velocity.
It's a good thing to know because we get this question a lot. We also talk to people about using the DSF, Cal DSF, right? So because that is for subsonic flight. So do you recommend that?
Sure. Yeah, you still have to cal the muzzle velocity first, but then after that, I mean, it gets increasingly difficult to observe your drops with 22 at long range because you end up with a lot of dispersion. Like you're shooting past 400 yards, 500 yards with the rimfire. The muzzle velocity dispersion that's inherent in that type of ammo is such that you have a tremendous amount of vertical dispersion at long range. So it's hard to really nail down exactly what your drop is. But if you shoot enough shots, especially on paper, you kind of find your group center, it's still possible to do that. Now, like I was saying in the beginning, we are adding rimfire ammo types in the library that include CDM. So if you're shooting an ammo type that's in there, you should have a pretty accurate prediction, with just a good muzzle velocity.
Got it. We had somebody ask about if the WES simulation model, so I guess like the AB, does that in subsonic? I believe that's what they're asking.
So I wonder if they're referring to the
I think
AB
the AB
analytics.
analytics.
Yeah.
Yeah.
Yeah, so that works the same way as well. If you set up a gun profile that's for subsonic, then it's going to do all those calculations the same. I mean, you'll see your hit percentage drop a lot quicker for a subsonic thing, but those calculations are still valid for subsonic.
Got it. We've been teaching Kestrel classes every 2 weeks now. We just do a Zoom class, and it's pretty cool. We get like 90 people from around the world. They all come in, they get to ask questions. And today, one of the guys asked, he's from out west where they get a lot of heavy rain. And this is total change in conversation, but he wanted to know if extreme heavy downpours affect the flight of the bullet. So he wasn't asking about relative humidity. He was actually asking about the downward force of that rain.
In my experience, no, that doesn't matter. And I've seen this in a number of times shooting where, the most prevalent memories that I have are coaching F-class team matches in Canada. And, we shoot in the rain if it's raining. And when you're coaching, you're watching in a spotting scope the trace of every bullet go down into the target and adjusting, the holds and keeping everybody centered. Well, in the rain, when you're watching the trace of 308 rounds flying down range, you can occasionally see little bursts, and those little bursts are the bullet hitting raindrops and vaporizing them. Now, it doesn't happen very often. Like, I think most people visualize like their bullet flying 1,000 yards through the rain, and it's, hitting raindrops constantly, and it's soaking wet when it gets there. Because if I went 1,000 yards in the rain, I'd be wet, right? Well, think about a bullet. It's so small, and the actual density of raindrops in the air is not very dense. Otherwise, you couldn't see your target, right? So the probability of a bullet hitting a raindrop, first of all, is very minimal. And I would say in a heavy downpour, a rain that makes it hard to see the target at 1,000 yards, in a string of 20 shots, you may see 1 or 2 shots actually hit a raindrop. And when you see those bursts, whenever a bullet does hit a raindrop, they show up right where they're supposed to on the target. I think it's just a momentum thing, right? Where the mass of the bullet and its speed is so much greater than the mass of the raindrop that any deflection that occurs is not great enough to really deflect the bullet a great deal.
Right. That's crazy. I mean, it's a cool thing to think about, right?
Yeah, the first time I saw it, I saw these bursts, and it was like they're almost like little lights. It's like a bright white burst is the best way that I can describe it. And I saw it, and I looked around. I'm like, did anybody see that? What? And it's rare that you see it because, like I said, maybe 1 or 2 out of 20 shots. But yeah, that I've only ever seen it when it was raining, and that's my interpretation of those bursts, is that it's a bullet hitting raindrops. Now, in practical terms, as a shooter in the rain, I know we wonder about the bullet flight and all that, but in practical terms, I think you have a lot more to concern yourself with on keeping your optics dry, keeping your lenses from having, mist build up on them, keeping your ammo dry, keeping water out of your chamber, keeping water from coming down your muzzle, like just keeping your equipment, your weapon system from getting water where it could cause damage is a much more practical problem of the rain than the external ballistics.
Yeah. Well, so what's the biggest problem of weather? Is it the wind?
Oh, the weather in general, just getting away from the rain?
Just away from the rain, yeah. If you go to a match, what is the one thing that you're like, I hope this is not this condition?
That's a good question, because the conditions are the same for everybody. So I guess the condition that I want is the adverse condition that I deal with better than others. as a competitor, like, for example, I don't do well in the cold. Like, if it's really cold, I can't put on enough layers. I'm miserable. My fingers get numb. Like, in temperatures that everyone else still seems to be comfortable with. So I don't stack up well when it's cold like that, but it can never get too hot. I say never. It's usually when it's so hot that other people are like falling out and bitching and wanting to quit. Like, I'm hot, but I can deal, I can deal with that. So, as a competitor, I guess you look for conditions that that play to your strengths,
Right.
I mean, obviously the wind, if the wind is up, it's up for everybody. So I guess the most that you can hope for is that everybody has fair conditions. Sometimes, you go to a match and it's only windy for the afternoon and not in the morning. And depending on when you shot, you could be either very lucky or unlucky. So, I usually just hope that for better or worse, it's pretty much the same for everybody.
Got it. But wind definitely, obviously with the Kestrel, we're a wind meter. That's part of it. And so we get asked a lot. The only part with the Kestrel that you can actually measure is where you are and how that wind applies, and then how the wind differs throughout the flight path of the bullet,
Mhm.
and how that affects everything.
Right. Yeah. So the being able to measure the wind where you are is very valuable. It's the only certainty that you have. It's the only thing you can measure directly. But it is true that the wind is not always the same all the way from you to the target. So it's a good example of knowing how to use the tools that you have, but also knowing when you have to use your brain and extrapolate, where you might have to use your imagination and say, I know what it is here, but I know the terrain features and it's not like this all the way to the target. So I need to put an adjustment on it, or just some kind of correction that I judge is correct based on, like when we were in Wyoming this last weekend, there was a stage that we shot from the tippy top of a mountain peak, and it was high winds. Like it was, we were measuring 30, 40, it even got above 50 miles an hour at sometimes. And what we had to be aware of is that on that peak, that wind that we were feeling and measuring, like right at the cusp of that peak, was not the same wind speed that was present everywhere along the whole line of sight. It was really concentrated right there on that peak. And so, we had to sort of adjust our reading that we got there to get accurate wind calls for those shots in that case.
So do you try and average it out to what you believe it is? What's your best practice? What do you do?
I mean, it really depends. I try not to um, hold too tightly to specific rules of thumb. I guess the biggest approach, or the biggest philosophy that I have about the wind, is to be flexible with it. Like, because I don't want to lock myself into rules that are developed around certain types of terrain or certain regions. So I try to understand why things work in some places, and recognize when I'm in the same kind of place or in a different place. And the policy of being flexible lets you keep your mind open to what might be different about these different places. So you can just have an open mind and apply the best strategy for where you're at. And then also staying flexible after you've made an assessment to be open to the cause effect, the connection between what I'm seeing in the cause of the wind and where the effect of where the bullet is landing. So, being open to that and being open to change your mind, because sometimes, you'll find an indicator that seems to be true and you're going off that indicator and using it successfully. And if you hone in on that and stop paying attention to everything else, it's very common that suddenly your bullets will start to not correspond to that indicator anymore.
Right.
And if you haven't been looking at other stuff too, you might not know what other indicators to look towards now. So even if you have an indicator that seems to be working, it's a good idea to still pay attention to other things as well. Because you might see that another indicator changed and this one stayed the same. Well, see what that first shot does, and then decide that you might have to start looking at another indicator.
Yeah. What about as far as temperature change shifts that you see throughout the day, humidity shifts? Like we always talk about that the Kestrel is a great place to learn, to learn. You use it to learn, and especially now that everybody's been stuck in their houses, they can sit there and play around and see those things. But how often do you think it's, for you personally, how often do you update environmental conditions? How often are you checking to make sure that you're on top of that?
Yeah, the way I decide that is, it depends on the size and the range of the targets. Okay, if you're talking about relatively big targets at relatively short ranges, you probably don't have to update your atmospherics at all, because the error is not going to put you off the target.
Right.
But the smaller your targets get, and or the farther away they get, the more critical it becomes to hone in on all those variables and make sure that they're not getting out of check. Because at that point, a small amount of error will be a large misdistance in relation to your target. It reminds me, there was a short story that one of our college professors told us that I'd never forgotten, and it makes good sense in this way. We were talking about the World Cup of sailing, okay, like the sailboats that race and the state of the art kind of modern aerodynamics that goes into designing sailboats. And just as an exercise, he kind of posed a question to the class, like, what do you think is the single most important variable of the race or of the boats that determined the winner? So we're all guessing like, oh, the sail or the keel or the surface finish or all these things. And the answer is that the most decisive thing is the conditions on the day of the race. Because, is it smooth water or is it rough water? Because your boat is either optimized for one or the other. And if you're optimized for smooth water and the water isn't smooth, it's very difficult to overcome that. And so to me, this really relates to, as a shooter, understanding what condition you're in, and in particular, the nature of your target that you're trying to hit. New shooters that come in and try to understand all the details and do everything right are always thinking about spin drift and Coriolis and wind and drop and all this stuff. But experienced shooters understand that, they may understand all those details, but if they're shooting at a full IPSC silhouette moving target at 400 yards, you can immediately just ignore 90% of those details and just get your lead right and break a good shot. And that's what's required to hit that target. Like, what's required to hit a target it changes depending on what the target is. And that I always think of that, boats in smooth waters or choppy waters. It's like, you got to understand your conditions, understand the target, and understand the correct tactics for engaging that target.
So, you have done all types of long range competitions and shooting competitions. Obviously, going between F class and a PRS or an ELR, those are definitely different kinds of rifles, different calibers. But when you stay within one type of shooting, because of all of this, do you choose different rifles or different calibers based on what the conditions are going to be that going into that? Is that a decision factor for you?
Well, in F class and in Palma shooting, the equipment is sort of determined by the rules.
Right.
Like, you've got to be 308s, and you have some liberty to select a bullet unless it's international shooting, and then even the bullet is determined. So, but in PRS, for example, I've only shot a couple PRS style matches, and this ELR match, I was thinking, wow, this is like goes out to 2,100 yards. The average target ranges and sizes are such that, I really want something that's high performance because it's Wyoming. It's going to be windy. I'm trying to think of the conditions, and so I took a 338 enabler to that match. That's, a neck down 375 enabler that we shoot in the 2 mile matches. And so that shoots a 300 grain bullet at 3,150 feet per second. That's like tremendous performance compared to most of the PRS, 6.5 style guns that were there. And, I thought, well, if nothing else, I'm not going to be outperformed ballistically.
Right.
But what I learned at that match, though, was that, that ballistic performance helped me, but that style of match I don't think is mostly determined by ballistic performance. I think that style of match, that field shooting where, we were on the range over 12 hours the first day, it's mentally and physically exhausting carrying our gear. Like, the circuit is at least a mile. And, it's by the end of the day, your ability to just focus and not make mistakes in marksmanship, I think is meant a lot more points than, your ballistic performance. So yeah, you can talk about selecting optimal equipment for things, but I try to not talk too much like exclusively about equipment when it comes to these competitions, because at the end of the day, it is a shooting contest. You as the shooter are going up against me as the shooter. And if the contest is structured correctly, it should reward good shooting. Otherwise we could just give out awards based on paper who's got the best ballistic performance, and it does not fall out that way. Some, like I, with my 338 enabler, I don't think there was anything at the match with better performance than that. I was 80th place, okay, out of 200. Now I learned a lot from that match about how that kind of stuff goes, but yeah, you can't overcome bad fundamentals or inexperience with ballistic performance. It can give you an edge if you already are doing other things right, but it's not going to be the thing that makes the big difference for you.
Yeah, and with that match too, I'm sure, I've been shooting in places where the wind is just beating you all day. To be out there for 12 hours and have that wind just driving into your face or driving against you it's grueling. It's really grueling.
Oh yeah, the wind and the sun and the dust in your eyes. Like at halfway through the day, I was past my peak of being able to concentrate.
So changing a little bit, we had some questions about tall target test. So doing sight scale factor, and now I might get killed for this, but our next Kestrel release, our next firmware release, we're going to add in sight scale factor. Mm-hmm. So with that, we know that there's going to be some questions and people are going to revisit how to do a tall target, how to do all of that. So do you want to talk about that a little bit and how that process works?
Yeah, sure. So tall target testing is a very important fundamental step in understanding your long range rifle zero, or your sights. Okay, so I think most people that come into shooting come into like not long range shooting first, and then get into further ranges. And a basic rifle zero that you get at 100 yards, okay, or 100 meters is important for obvious reasons, right? If you want to hit a 50 or 100-yard target, you've got to at least zero your sights there. Well, for a long-range rifle, for any setup you're going to shoot at long distance, the tall target is the extension of the basic rifle zero. Okay, it makes sure that your rifle is zeroed at 100 yards, but that also whenever you dial up to correct for drop at long range, that correction is an accurate correction. I think a lot of shooters they slap on a scope and they just assume that when they dial 10.4 mils, they're getting exactly 10.4 mils, yeah, and perfectly level and exactly up. And sometimes it works that way, but usually not, unless you have, taken the steps to ensure that your sights are level and that your scope is tracking as it should. It usually doesn't just fall together like that. So the tall target test does two important things. One, it ensures that the magnitude of movement that you get out of your turrets or your reticle, works in both ways, is accurate. So 10.4 mils gives you 10.4 mils and not 10.2 or 10.8. That has to be accurate, or else your ballistic solutions won't track with your scope. Right. And the other important thing that it does is to make sure that you don't have any cant in your scope, so that it's level. All right, because another thing that can happen is if you don't have an anti-cant device, a level, then it's real easy when you're shooting, especially in terrain, not on a flat range with a flat horizon. It's very easy to align your reticle with some natural terrain feature that has no obligation to be level, right? So it looks level, you think you're lined up, but you might not be. And the consequence of canting your rifle, rotating it one way or the other, is that you miss laterally, right? It looks like a wind error. And it can be very hard to diagnose because wind is a real problem. It's a real big problem. And if you're missing left and right, it's easy to think you're just missing the wind call, when in fact, you may just be canting the rifle. So the tall target lets you verify that your level is installed correctly, and that your point of impact is tracking, vertically up a plumb line at 100 yards or 100 meters, and that it's moving up the right amount. So just doing that work at 100 yards can put you so far ahead when you go to shoot long range, because at least you will understand that your sight is behaving as you expect. If you take that for granted and just assume that your sight is doing what you expect and go from 100 yard zero and then immediately start shooting long range, Well, if you're missing your targets at long range, you don't know why. You don't know if your ballistics are off, if your muzzle velocity is off, if the range is off, if the wind is off. You don't know any of that. But mapping it out on a tall target at 100 yards, like I never go to any competition or go to shoot any kind of activity where I expect to hit a target without running that rifle on a tall target before I leave, even if it's one that has already been put together. Like I just do it to verify, to make sure that everything is locked in how it should be.
So when you put your level, your anti-cant device on, you mount it on your scope, right? Not on, yeah. So when you put it on, do you first do it with a plumb line and then take it out and do the tall target test? Or do you just do everything right out there with the tall target test?
So what I do is I'll mount the tall target. I'll, draw the vertical line and come back and line up my reticle on that vertical line. And with it in that position, tighten the level down so that it reads level when my reticle is on that vertical line. Now, here's a detail that you don't want to mess up, and it's easy to mess this up. So whenever you're shooting the tall target, for step one, you shoot your 100-yard zero at the bottom, okay? And then you dial up your 10 mils or 30 MOA. And again, aiming at the bottom, you shoot another group. Now, here's where a lot of shooters will instinctually, because that vertical plumb line is in their field of view, they will naturally just line up their reticle with it and ignore the bubble, okay? That's not what you want to do. Because what you're trying to do is see if your bubble is accurate. And if you're doing that, whenever you shoot that tall target, you look at your bubble and level that up, aim at the bottom and shoot. Now, if your bubble is level, but your crosshair isn't on the vertical line, then that's a problem. That's the whole point of the exercise. So it's important that you are paying attention to your bubble and not your vertical crosshair when you're shooting the tall target. That's what's going to verify that your bubble's on correct.
Yeah, so you bubble up and then you just make sure that everything jives and adjust it all.
Yeah.
Got it.
In fact, like I will draw a heavy visible vertical line when I'm setting up a bubble on a scope for the first time, because you need to be able to see it. But after, like if something is already on and you just want to verify that the level is on right, it's actually smarter to draw a very faint, like pencil line that you can't see through your scope, so that you can't make that mistake. And
so
that way
your eye doesn't focus there.
Yeah. That way you're forced to use your level. And then when you walk up to the target and you see that faint line, you'll see if your group is on one side or the other. But it's a good way to not trick yourself.
Yeah, I've definitely had times where my bubble has slipped, like it's not fully tightened down. TSA goes into my case and screws around with stuff. And then like I'm in a hotel room trying to figure out how to get everything lined back up. So probably not the best case scenario.
Yeah, that would make me really nervous.
Well, we're not quite at the same caliber, so it's okay. So somebody else, go ahead. Sorry.
It's high on my list of like comfort things though, like to just knowing that the level is good on my scope and that I've done a tall target test and that my rifle has a 0. Like if I have confidence in those things, I have confidence in what I'm about to do with the match. If there's any of those things, if my 0 or my level or my tracking has not been verified to my comfort, to my satisfaction, well, who knows what's going to happen? You really can't expect anything if you don't know that.
Yeah. Changing pace again. So Colin just wrote into us and he would like you to explain aerodynamic jump in layman's terms. So the best way to account for it, full AJ lesson.
Yeah. Okay. So I'll do it in 2 parts. I'll try to explain what it is and how and why it happens. And then the second part, like whether or not you care about that first part or not, I'll try to give like here's what to do. Okay. So what aerodynamic jump is it's a consequence of the bullet coming out of the muzzle and having to realign its axis with the oncoming airflow. All right. So let's say you shoot out parallel with your line of sight and you have a crosswind. Well, that crosswind is going to make the bullet kind of weather vane a little bit. If your bullet's 3,000 feet per second and you have like a 15 foot per second crosswind, there's a very small angle that's proportional, like it's the triangle, the angle is proportional to those two legs, okay? So, and that's the orientation that your bullet ends up flying with. Now, anytime the axis of a spinning thing gets disrupted and forced to move, it reacts with a series of precessions, right? Like a top. You know, if you have a top that's in equilibrium on the table and you push the stem of that top, it will react and settle out in a new place. And so what's happening with aerodynamic jump is the bullet comes out, its axis is forced to realign with the oncoming air vector, which is adjusted by the wind. And as a result of that, it goes into a series of precession cycles. And it's called the first max yaw angle is down whenever you have a left wind deflecting your bullet to the right. And it's vice versa. If you have a right wind deflecting your bullet to the left, the first pitching and yawing reaction is the first max yaw is up. Now the bullet continues to oscillate and precess around its center, but it never goes down as much as it went up when the bullet is deflected that way. This is much easier to explain with graphics. I have illustrations in my seminars that I show for this, but it's hard to do with words. But that's what's happening. It's the bullet's gyroscopic reaction to having its axis jerked around by the wind. And it's a jump. So it's a point input, which means if it gives you 1/10 of a mil of vertical aerodynamic jump, that jump occurs in the first like 10 to 20 meters out of the barrel. And after that, it doesn't grow or shrink. It's that 1/10 of a mil deflection, and it'll be 1/10 of a mil at all ranges. Okay.
So it doesn't keep growing as it's going.
No, it's not like wind. Wind is pervasive on the trajectory the whole way. So it does have what looks like a parabolic deflection where it continues to grow. But the aerodynamic jump is just, you get a deflection, an angular deflection, and then it holds that. It's just on a new path now. So that's what happens. Now, how to deal with it that's the beauty of the Kestrel. You input your wind conditions into the Kestrel and it calculates aerodynamic jump behind the scenes. So and it's based on your wind 1. So if you have a wind 1 at 10 mile an hour at 9 o'clock, it's going to show you that you have a deflection to the right. You're going to need to adjust to the left to account for it. And it is also going to tell you to dial up a small amount from what you would in a no wind condition. So as far as what you do about aerodynamic jump, all you have to do is be careful about your wind inputs into the Kestrel, and it will account for aerodynamic jump behind the scenes.
Now, Colin followed up with, if the axis is shifted into the wind and the bullet is pointed, wouldn't that cause flight path shift into the wind and help fight the wind drift?
So no. So because the bullet is losing velocity, that is why it has drift. So here's an interesting thing. If the bullet had thrust, okay, the bullet had more thrust than drag. It came out of the bullet and thrusted and accelerated, it would deflect into the wind. In fact, that's how rockets work. If you fire a rocket, a tail stabilized rocket into the wind, it weather vanes into that wind vector, but since it has more thrust than drag, it is pointed upwind. The wind just reorients the drag vector. Okay, the wind just orients that vector. And if you have more thrust than drag, you will accelerate upwind. That's how rockets fly in crosswinds. But bullets, because their drag is the dominant force that's slowing it down, the bullet aligns its drag vector with the wind, and now it's slowing down. So, and it's that lateral component of the bullet's shifted axis that pulls it away from the line of sight then.
Got it. Colin has not asked another question, so I think we got him covered.
Got to the bottom of it.
Yeah.
It's an interesting question because I think it comes together when you understand about rockets. And so like airplanes that are maintaining their speed in a crosswind, they'll fly at a crab angle, but thrust equals drag for an airplane that's flying at constant speed. So it just continues to not be deflected by the wind, not go upwind, but if it's maintaining its speed, it's just flying at a crab angle.
Right. Sorry, I just lost my whole train of thought because I looked at the video to ask him another question, but For aerodynamic jump, I mean, the wind is super critical. That's what is in the Kestrel. Sorry, in the Kestrel, your wind one is what is giving that aerodynamic jump input into your elevation hold, as well as your, I mean, and then your wind one is obviously affecting your wind hold. Situations like you were in Wyoming, when you were just shooting at the top of the mountain and you were seeing 50-mile-per-hour gusts where you were standing, but you realized that that wind gust was not 50 miles throughout the entire flight path. How would you put that into the Kestrel to properly adjust for aerodynamic jump?
Yeah, that's a good question, and that's where it gets very difficult to have it work in all scenarios. The same thing could apply, like if you're in an area, it's actually more common, I think, to be in an area that's sheltered from the wind for the first 20 meters, and then your trajectory gets exposed to crosswind. So in either one of those cases, I think that the shooter just has to understand the situation that they're in. And if you're like in the case we were in Wyoming, where we knew the wind was hitting us harder where we were than it was all along the trajectory, in that case, you could get your wind solution. I guess you'd have to get them independently, like put in what you think. I need to back up here. I need to be careful. Because it's the wind right at the muzzle that determines your aerodynamic jump, then that's what you would put in to get your aerodynamic jump. So let's say the wind is 50 miles an hour at the muzzle, but it's really an average of 30 miles an hour for the whole way. You would want to base your wind solution on 30 miles an hour, because that's what your real wind is most of the way. But your aerodynamic jump needs to be based on 50 miles an hour. So what I would do in that case is put in 50 miles an hour for wind one, get your AJ corrected elevation, and then put in a 30-mile-an-hour wind to get your
left, right.
Your left, right, yeah.
Interesting.
In fact, you could have 30 miles an hour be your wind two and use wind two for your wind solution, and then ignore the wind one deflection and use the other one.
But use your elevation that way. Yeah.
Yeah,
cool.
It's a good thing we're talking about a small effect here, because I understand how this can be confusing, especially if you have to do it quickly. In most cases where the shooter is in the wind condition that their bullet is spending most of the time, then everything takes care of itself. It's only when the first 20 meters of bullet flight is a dramatically different condition than the rest of it. So let's say the bullet is flying in a no wind condition, and say it's sheltered from the wind until it gets out there to like 50 meters and then it gets hit. Well, all the same stuff still happens. There is still a jump, but since it occurs so far away, that few thousandths of an inch that it jumps is much smaller angularly than it would have been if it happened close to the muzzle. Does that make sense?
It does.
Like on your scope base, like if you bump your scope base and it moves 1,000th of an inch, and your front and rear scope mount are like 3 inches apart, well, that 1,000th of an inch over 3 inches is a huge angle. But if you bumped it 1,000th of an inch and it was 10 feet long, well, that's a much smaller angle, and you can pretty much ignore that. That's right. Kind of how you would think of aerodynamic jump. As far if it happens right at the muzzle, then it's really, you're going to see that as a substantial angular effect, 1 or 2 tenths. But if your bullet doesn't encounter that until further out there, then it's getting the same number of thousandths of jump, but it's a much smaller angle.
Got it. So that is a really complicated and involved subject for sure, because we talk about, most people are shooting in some kind of dirty air, and there's, if you're sitting on a berm and the wind's coming up and hitting you up at the front, or however that's working. So I feel like it's going to be a topic that we're going to have more discussions on for sure, trying to figure out when to use it, when not to use it, that kind of stuff. Do you have any other insight on, like, if it's only 5 miles per hour, obviously you can put all this in. And again, with the Kestrel as a learning tool, you can put it in at 5 miles per hour, you can put it in at 10 miles per hour, and you can see where those wind speeds are actually going to make an effect big enough for the size of the target at the distance that you're shooting for a miss, right?
Yeah, and it, wind is hard. Wind is a difficult thing. There's no easy way to boil it down and understand these complex wind fields through terrain. I mean, because in addition to the aerodynamic jump, you could have actual vertical wind currents working on your bullet too. You know, if you're shooting, you know, if your line of sight goes up along a slope and you have a tailwind, then you know you're going to have some component of wind blowing up through your line of sight, and that is going to deflect your bullet upwards. You know, you can.
Right.
So it's really, it's not easy. And one time you really have to think about this is if you're truing. So if you're trying to true your muzzle velocity in high wind, it's very dicey. You know, if you have to do that, make sure that you're putting in accurate wind inputs and you're accounting for everything as best you can. But even then, if the first opportunity that you get to true again in a calmer condition, you really should, because the wind at long range can bake an error into your drop and therefore into your true muzzle velocity. So, you know, muzzle velocity truing and DSF truing, these are calibration exercises. So you want to do them in as pristine conditions with the best observational abilities that you can get. And wind really complicates that.
The same goes, I assume, for the tall target test, right? Even though it's only 100 yards, 100 meters, if you have wind gusting through there, you probably, it's going to give you some false readings, right?
Yeah. Same thing with zeroing in tall targets, you know, especially with a lot of the fast twist rifles that guys are shooting. The magnitude of aerodynamic jump, in addition to the crosswind speed, it also depends on the stability of the bullet. So a bullet that is just barely stable has a lot less aerodynamic jump than that same bullet if you shoot it out of a much faster twist. The more stable the bullet is, the more aggressively it reacts to that gyroscopic correction and the angle of deflection. You know, we talk to visualize it on a target. It's like a 10 o'clock to 4 o'clock angle for right-hand twist barrels. And, you know, if you're shooting extremely fast twist, making the bullet have a lot of stability, instead of 10 to 4, it can be more like 10:30 to 4:30. It can be a lot more aerodynamic jump for more highly stabilized bullets.
So wind matters all the time, but does it matter when you're getting your PDM? So if I can find the AB Mobile Lab, it's high winds, are we still good to go with the Doppler?
Yeah, because so with radar tracking, you get to ignore all that stuff that moves your trajectory around, right? So like a crosswind, you could have a nasty crosswind, and all the radar is measuring is the velocity decay of the bullet and along the line of sight. So if it gets deflected sideways, doesn't matter. Where the wind can affect the ballistic calculation of the radar track is if you have a strong headwind or tailwind, right? So whenever we take the conditions for a radar test, you know, obviously we're doing temperature, pressure, humidity, getting the atmosphere characterized in terms of density. But also then if there's a very strong head or tailwind, that can affect how the bullet slows down, and that gets accounted for in the ballistic calculation of the radar track.
Got it. Do you have, we are almost completely out of time, but that was kind of a key into the AB Mobile Lab and where people can find it through the end of the year. So do you have some dates, times, places?
Yes.
Vague?
So we've had to push a couple of these because the events got canceled or moved, but in fact, we were supposed to be at the Night Force match, but the venue changed last minute and we couldn't really get to the new venue, but we're going to be there next year at the Night Force Steel Challenge in Wyoming. Right now, the lab is on the road to the Vortex Sandstorm PRS match in Ohio. It's going to be there this weekend. July 25, 26, there's a Guardian long range match at MTC here in Michigan. We're going to be there with the Mobile Lab. July 31st to August 2nd in Wisconsin is the Barrel Maker Classic, and we're going to be at that match in Wisconsin. August 21 to 23, the Garmin match at the Ringneck Ranch. It's an ELR match in Kansas. And then it says October 2 to 4, Bushnell Gap Grind in Tennessee. And I know that we're going to be at the King of 2 Mile match as well, which I think is also in October. It's just getting moved now. So check our website for this calendar. We're going to continue to update it. So if you want to come to an event where we have the Mobile Lab and get a PDM for your rifle and your system, we'll be there for you.
If people are not shooting the matches, are they allowed to bring their rifles in and still go for the PDMs?
Sure.
Awesome. All right, there's like binging. That might be our time.
No, that's my Facebook phone.
Did you set an alarm on us? All right, well, hopefully we get to see you in person soon. Hopefully we can work out the Kestrel match and get you guys down there. If not, we'll get to see you soon, and maybe even do a class. If you want to come in and do a Facebook Live class or a Zoom class with me, I'd love to have you do that.
Okay.
All right, well, I really appreciate your time, Bryan. It's been great talking to you. It's been great learning some stuff. And I'm sure everybody that's on Kestrel Ballistics has appreciated it as well.
Well, it's good to be on. Thank you for having me.
Yeah, thanks.